The radius of a cylinder is increasing at the rate of 2 centimeter per second. So we are talking about a cylinder whose volume is pi r square h and its altitude is decreasing at the rate of 3 centimeter per second. So find the rate of change of volume. So we are talking about dV by dt. When the radius is 3 centimeter and the altitude is 5 centimeter. This altitude is 5 centimeter, radius is 3 centimeter. So it is increasing, radius is increasing. Increasing, we always use a plus. So we have dr by dt, which is given as 2 centimeter per second. And altitude is decreasing. So whenever it is increasing, we always use the positive sign. Whenever it is decreasing, we always use a negative sign. So it is 3 centimeter per second. I'm going to put a negative here just now. So you just have to differentiate the volume, dV by dt, radius is given, altitude is given, dr by dt is given, dh by dt is given. So this is for your reference, but we are going to solve it. Pi r square h is the volume and we are going to differentiate this. dV by dt is equal to, pi you can take common. So r square, differentiation of this h is dh by dt. We are applying the product rule here. It is dh by dt plus h. We have r square is 2r dr by dt. Now, as I said, the increasing is plus, the decreasing will always be negative. So you have to put a negative in front of 3. dV by dt is this one. So we have a r inside, so you can just take r common. So you'll have pi into r is radius is 3 in this case, and then this r into dh by dt, 3 into pi, then we have 3 into dh by dt, which is minus 3. Now we have this 5, h is 5 into dr by dt is 2. So this is 33 pi centimeter cube per second. This is the answer which is going to come. The volume of a metal in a hollow sphere is constant. Hollow sphere means what? That a ball, without quite a thickness. So we will have two radiuses here, the inner radius and the outer radius. So volume of a metal in a hollow sphere is constant if the inner radius is increasing at a rate of 1 centimeter per second. Volume is what? Of a hollow sphere. It is the outer volume subtracted by the inner volume, and the volume is 4 by 3 pi r cube. If you take the capital R and small r, capital R for the larger radius and r for the inner radius. So volume is 4 by 3 pi r capital R cube minus 3 this r cube. So the small r by dt, the inner radius is increasing at the rate of this. So dr by dt is minus is increasing. So when it is increasing, we are not going to use negative. I'll just change it. See, always increasing is plus, decreasing is negative. So the radiuses are given, the small r and capital R, the bigger one will be capital R, smaller will be the 4. Find the rate of increase of outer radius. So dr by dt is to be found out. Now you will be able to do it. We already have a volume relationship. You just have to differentiate it. So dV by dt you have to compute, and we already know it is 4 by 3 pi. We can take it outside. R cube, differentiation of r cube will be 3r square d capital R by dt minus this small r cube will be 3r square, and then dr by dt, small dr r here. Now dr by dt is to be computed, that is the higher radius. Volume of a metal is constant. So when you do dV by dt, volume is constant. It will be some value. When you differentiate a constant value, what do you get? It is always 0. So on the left you are going to get 0. 4 pi by 3 doesn't count. The inside bracket will count, so you can take one on the left hand side, other on the right hand side. So 3r squared dr by dt is equal to 3r square dr by dt. So this dr by dt is going to be r square by capital R square, means small r square by capital R square, into dr by dt. So it is 4 square divided by 8 square. Dr by dt is 1. As I said, it is increasing. So the negatives will not count. Always decreasing will be using the negative. Increasing will always be positive. So when you compute this, you will get 1 by 4 centimeter per second, and this is going to be d capital R by dt. So you just need to know the volume of the hollow sphere, which is 4 by 3 pi capital R cube minus small r cube, and that's how this is the actual thing. If you know this, other things are just the customary routine things which you have been doing since we started understanding the differentiation. So the answer here is 1 by 4 centimeter per second. One more thing I would like to highlight: negative for decreasing, positive for increasing. Any rate. Sand is being poured onto a conical pile at the constant rate of this. 50 centimeter cube per minute, such that the height of the cone is always 1/2 of the radius of its base. How fast is the height of the pile increasing when the sand is 5 centimeter deep? Okay, first of all, you need to know the volume of a cone. So this is how it is being formed. When you drop the sand, even if you drop it anywhere, you'll see it will form a cone, because there will be a base and there will be a top. That is, the recent sand will settle on the top. Now, there are certain things which are given, that is height is radius by 2, that is the height is always half of the radius of its cone. 50 centimeter cube per minute is your dV by dt, because it is rate of change of volume, dV by dt. So you write 50 centimeter cube per minute, and the relationship between H and R is already known to us. H is R by 2, and we are going to use it because we are interested in finding out how fast is the height of the pile increasing when the sand is 5 centimeter deep. So we need dH by dt, so we need to eliminate the R in the volume, and when we eliminate the R, we have to put R as 2H. Volume is 1 by 3 pi R square H, and dH by dt has to be computed like this. dH by dt. First R is 2H. So in place of R square, just put 2H whole square. H will be already there. And this is volume. So you'll get 2H square is 4H square. So 4 by 3 pi H cube. H square into H is H cube. dV by dt we have to compute. So when you differentiate this and put this dH by dt on one side and other things on right hand side, because height is already known to us, which is 5. Radius we don't need because we already know the relationship between radius and height. So you will have to put in place of dV by dt 50. 4 pi will already be there, and in place of H just 5 square. So this is dH by dt. This is going to be 1 by 2 pi centimeter per minute. This is your result. A kite is 120 meter high and 130 meter of string is out. If the kite is moving away horizontally at the rate of 52 meter per second, find the rate at which the string is being paid out. So you are actually flying a kite, and the kite above the ground is 120 meter high, and the string length, that is it will be at some angle from the ground, and it is at 130 meter string out. Now this kite is moving away horizontally at the rate of 52 meter per second. Find the rate at which the string is being paid out. So rate at which the string is being paid out, let us say that you are standing here, and then the kite is above the ground 120 meter, and this kite is moving horizontally in this direction, which I just showed you by the arrow. So 120 meter is this one, kite is moving in this direction. X, let us say the rate of going at horizontal direction is this one, and this Y is the rate at which the string is being say released. The thing which the question is said is being paid out, which is actually equal to the rate at which the string is released. So let us use the Pythagoras theorem. X square plus this y square is equal to x square plus 120 square. And let us differentiate this. 2x dx by dt is 120 will be 0, 2y dy by dt. Now you can just cancel this 2, and there is a relationship between x, y, dx by dt and dy by dt. So we need to find out dy by dt, as I suggested, the rate at which the string is being paid out. So dy by dt is x by y divided by dx by dt. So x, there are certain values which are known to us. Alright. So we need one more value here. That is, y is 130 here. It is already given. 130 meter string is out. Dx by dt, which is the rate, is also given 52 meter per second. X is to be known first. So 120, this is 130. So in order to get this x, it will be, we'll use the Pythagoras theorem again. So all the things which are known, I have just put it up, and next thing will be x square plus 120 whole square is equal to 130 whole square. So we get 130 whole square minus 120 whole square under root is as x square. X will be equal to, this is going to be directly, I'm writing it is 50. This is the final value. So this is 20 meter per second will be the final answer. This is dy by dt. A particle moves along the curve, and this curve is y equals 2 by 3 x cube plus 1. Find the points on the curve at which the y coordinate is changing twice as fast as the x coordinate. So dy by dt is actually equal to twice of dx by dt. This is the question asking. Dy by dt is equal to twice of dx by dt. Now we have y is equal to 2 by 3 x cube plus 1. This the particle is moving along this curve. Now we need to differentiate both the sides. So dy by dt will be equal to, this is 2 by 3, x cube will be 3x square followed by dx by dt, and differentiation of 1 will be 0. So there is a relationship here, but there is one more relationship I told you in the beginning. dy by dt is twice of dx by dt, and we are interested in, I am replacing dy by dt as dx by dt, twice of dx by dt. So this gets cancelled, this also gets cancelled. dy by dt also means dx by dt we have replaced for dy by dt, twice of this. So x square minus 1 is equal to 0. This will be x minus 1 into x plus 1 equals to 0. So x will be 1 and x will be minus 1. Now what will be the value of y corresponding? For x equals to 1, y will be equal to 2 by 3 1 cube plus 1. Here y will be equal to 2 by 3 negative 1 whole cube plus 1. So 2 by 3 plus 1 and minus 2 by 3 plus 1. So 1 plus 2 by 3 is 5 by 3. 1 minus 2 by 3 is 3 minus 2 by 3, 1 by 3. So 1 comma 5 by 3 is first, minus 1 comma 1 by 3 is the second point. Find the point on the curve y square equals 8x for which the abscissa is x, ordinate is y, for which the abscissa and ordinate change at the same rate. So dx by dt is equal to d by dt is given in the question. So the curve we have to differentiate. Y square equals to 8x. So this is y square equals to 8x. Just differentiate both the side. 2y dy by dt is equal to 8 dx by dt. So dx by dt is dy by dt. They both are equal. So 2y dx by dt equals to 8 dx by dt. You can cancel these two out. Y is directly equal to 4 here, and since x is y square by 8, you can find out x from here. That is y is 4, so 4 is 16 by 8. It will be 2. So for x 2, y is 4, so 2 comma 4 is the point where abscissa and ordinate change at the same rate. The volume of a cube is increasing at the rate of 9 cm cube per second. dv by dt is given as 9 cm cube per second. How fast is the surface area increasing when the length of an edge is 10 cm? So surface area is ds by dt, increasing when the length of an edge is 10 cm. So x is equal to 10 cm. So volume of a cube, we have already seen that if there is a cube edge or side, we take it as x, volume will be equal to x cube. Surface area of a cube is 6 into side square. So volume equals to x cube, dv by dt will be equal to 3x square dx by dt, and this dv by dt we already know it's 9, x is 10, put it here, 3 into 10 square, dx by dt can be computed from here. This is a 9 divided by 100, this 3 divided by 100 is 0.03 centimeter per second. This is your dx by dt. Now how fast is this surface area increasing? So we are interested in ds by dt. Surface area, as I just suggested, surface area of a cube is 6 into the side square. So 6 into side square is surface areas. So you can just write this, and then you can differentiate this. ds by dt is equal to 6. X square will be 2x dx by dt. So 6 into 2 into x is what? You have x as 10. And dx by dt we have just computed. It is 0.03 centimeter per second. When you compute this is going to be 3.6 centimeters square per second. ds by dt, that is the rate of change of surface area, is 3.6 centimeters square per second. So dx by dt computed and then placed in the ds by dt. The volume of a spherical balloon is increasing at the rate of 25 centimeter cube per second. So dv by dt is given as 25 centimeter cube per second. Find the rate of change of its surface area at the instance when radius is 5 centimeter. So radius is 5 centimeter, ds by dt has to be found out. So we have already done question like this. So volume is 4 by 3 pi r cube. Surface area is 4 pi r square. So volume is 4 by 3 pi r cube. dv by dt will be equal to 4 by 3 pi 3 r square dr by dt. And r we already know, 4 by 3 into pi into 3 into 5 square. dr by dt can be computed from here because dv by dt initially I told you it is 25. So when you solve it, you are going to get dr by dt as 1 by 4 pi centimeter per second. Now rate of change of its surface area. Surface area is what? 4 pi r square. ds by dt is equal to 4 pi 2 r dr by dt. That is going to be 8 pi r dr by dt. This r is 5. dr by dt we have just computed as 1 by 4 pi centimeter per second. So this ds by dt will come to 10 centimeters square per second. The length x of a rectangle is decreasing. X is the length, is decreasing at the rate of 5 centimeter per minute. So length is dx by dt. So this is decreasing. So it has to be negative 5 centimeter per minute. And the width y is increasing at the rate of 4 centimeter per minute. So dx by dt was negative 5, dy by dt, because it is increasing, we have to put it in the positive, it is equal to 4. So when x is equal to 8, y will be equal to 6. Find the rate of change of the parameter. Just see when this x and x8 and y6 will be utilized. You'll see here. So this is the rectangle. The opposite sides of a rectangle they are equal, and the perimeter is simply twice of x plus y, because if a length is x, width is y, twice of x plus twice of y, which is the perimeter. So dp by dt is 2 dx by dt plus dy by dt. So you don't have to do anything. Dx by dt is with you, dy by dt is also with you. Just put it here and answer will be there. Now, as I said, what about x equals to 8 and y is equal to 6? So this will not be used. This is just redundant, just to confuse you. Okay, so there is no use of this 8 and 6 in this question. Just put negative 5 and 4 in place of dx by dt and dy by dt, and just compute. This is going to be negative 22 centimeter per minute. This is your answer. So this is your x, this is your y, and this is how it's to be computed. Again, the same question. See, these questions are exactly similar, but now we are talking not about the perimeter, we are talking about the area. So this dy by dt is 4 in this case, which is positive, we are going to take. Dx by dt, since it is decreasing, that is decreasing at the rate of 5 centimeter per minute, dx by dt is negative 5 centimeter per minute. X is given as 8, y is given as 6 centimeter. Now we are interested in area. Area is what? Length into breadth, or length into width. So it will be x into y. dA by dt will be x, dy by dt plus y dx by dt. Now we are going to use this 8 and 6 in this question. So x is 8, dy by dt, y is 6. So these both value we know. Dx by dt is negative 5, dy by dt is positive 4, and when we compute this, it's going to be for the 32 minus 30, that is going to be 2 centimeters square per minute. So this is dA by dt. Okay, here 8 and 6 is utilized. In previous question it was not being utilized. A circular disc of radius 3 cm is being heated. Due to expansion, its radius increasing at the rate of 0.05 centimeter per second. So radius is 3 centimeter. dr by dt is increasing, so it will be positive 0.05 centimeter per second. Find the rate at which its area is increasing. So dA by dt is what we have to find out when the radius is 3.2 centimeter. So dA by dt will be pi. This is 2r dr by dt. So 2 pi r dr by dt. When the radius is 3.2 centimeter, let's see. So this is 0.32 pi centimeter square per second, because it is going to come, all the things are given. That's why those who want to do by themselves, the answer will be 0.32 pi centimeter square per second, because r is 3.2, dr by dt is 0.005 centimeter per second. This is your final answer. So this is all about this exercise. Thank you so much and take care of yourself.